Good morning everyone. Welcome to the solutions for the fifth video. So yesterday I had put up the fifth video. Today we are continuing with this. Okay, now let me go back to this. Okay, fine. Now, the first problem states the cyclist accelerates in a straight line. At one instant, the cyclist is exerting a forward force. Just a minute. Okay, this is the cyclist. He is moving. Forward force is 40 Newton. Backward force is 10 Newton. And here is asking you what is the rate of change of momentum. What is change of momentum? Change of momentum is nothing but delta P. What is rate of change of momentum? Wherever there is a rate here before any quantity, you just need to divide this by time. That's it. Now, according to this, what is this delta P by delta T? Now, what we do is, let me write this as delta of M into V divided by time taken, which should be, now I will remove this M because what does delta refer to? Change. If I remove this, I get this as M into delta V by T, which is once again, I can write this as delta V. What is delta V? Final velocity minus initial velocity divided by time taken. Do you recognize this? What is this? There's nothing but your M into A. What is M into A? Force, right? If it is force, what force? Net force. There is your net force. So what is the problem is asking? The problem is asking you to find out what is the net force. Simple. So towards it. Now 40 newtons acting like this, 10 newtons acting like this. Net force should be 30 Newton, 40 minus 10. So therefore, the answer here is 30 kg meter per second square. How do I know kg meter per second square? The reason is because M into A. What does M into A tell you? M is kg. Acceleration is meter. Acceleration is, just a moment, meter per second square. Meter per second square. That's it. You got the right answer. Okay. Now let us move on to the next one. A thin-walled cylinder of weight W opens at both the ends rests on a flat surface. So you have something like this cylinder has a height L, average radius R, a thickness X, and R is much greater than X. Okay, so everything is given here. So you need to find out what is the pressure. So you have a cylinder kept over here. So what is pressure given by? Pressure is nothing but force divided by area, right? So what is force? Force, where do we get a force? Do I apply a force? I don't apply a force, right? So where does the force come from? Because of the weight of the object, and hence there is a pressure imparted on the surface. So I'll write this as W. Divided by area. Which area? Now many of them commit a mistake here, thinking that it's a circular cylinder. I can just put this as pi r square, which is incorrect. Why is it incorrect? The reason is because the area here is not the full area. Okay, the empty space over here does not impart any force. It does not give any force because it's empty space, right? Where is the weight coming from? The force is coming only from the perimeter of the cylinder. So you need to consider only that area. Now, how do I consider that area? Let me do a simple experiment. So first I'll draw one circle. What is the circumference of the circle? 2 pi r. Now, if I continue to draw circle on top of it, now you see, I have drawn circles on top of it. So many circles I have drawn. Right? Now you see, if I ask you what is the area, then what will you say? You will say this is 2 pi r multiplied by the value of x. What is x here? The thickness. So therefore, the right answer should be 2 pi r into x. I have seen many students working out or giving out an answer as either this or this, but both are incorrect. Remember, the area here should only be with respect to what mass is in contact with the surface. Thus, A should be the right answer. Okay, now let us move on to the next one. A stone falls from rest to the bottom of a water well of depth D. Time taken is given to you. Okay, what is time taken? So if you notice this, this is T is equal to T0 plus or minus delta T. So which is nothing but 2 plus or minus 0.2 seconds. Okay. Now depth of the well is already given to you, which is 20 meters. And you need to find out the uncertainty in T, absolute uncertainty. I had already told you, absolute uncertainty will have an unit. Percentage and relative will not have an unit because it's a ratio and ratio multiplied by 100. Okay. So therefore now we have D is equal to half AT square. Delta D divided by D is equal to delta of half divided by half plus delta of A divided by A plus delta of 2 times delta T divided by T. Now this is a constant, so this goes to 0. Now here you see uncertainty in A is negligible, which means he treats this also as a constant, goes to 0. So what I am left out with only this value. So this should be 2 times delta T by T. Now let us substitute here. What is delta T? Delta T is 0.2. 2 into 0.2 divided by, what's the value of T? 2. So the net answer you get is 0.1 over here. What have we got? We have got delta T over here. Delta T is equal to delta T by D equal to so much. Now I want to get the value of delta T, which should now be equal to D times 0.1. What's the value of D? Value of D is given by 20 meters. So 20, oh my God, 20 multiplied by 0.1 will be equal to, right? No, this is 0.2 here, sorry. 0.2 should now be equal to 4 meters. Okay, so the answer is plus or minus 4 meters. Now let us move on to the next one. A projectile is fired horizontally from the top of a cliff. Let us draw the cliff. This is a cliff. Cliff is nothing but a mountain or a tower. Okay. The projectile is fired horizontally. Mark the term horizontally. Horizontally. The projectile hits the ground 4 seconds later. When you fire it here, what will happen? Gravity will pull it like this. So it will fall like this. Just a minute. You have a projectile. Just give me a moment. Okay, let me continue. So this is my tower. And I have a projectile. When I fire it horizontally, it falls like this. It falls at some point here. When it falls here, what is the time taken? Time taken is equal to 4 seconds. Let this height be h. And then at a distance of 2 kilometers from the base of the cliff. This is 2 kilometers. So what I will do is, I'll write this as 2000 meters. What is the height of the cliff? What is this height? So what do you do here? Now along this direction, it is ux. Along this direction, it is uy. Now let us write ux is unknown. I do not know what's the value. Just throw. What is uy? Uy is equal to 0, right? And what about distance over here? If I take this as my origin, this is my positive x-axis, this is my negative y-axis. So therefore, the displacement should be negative. Now displacement is negative. Yes, y is equal to minus h, which I need to find. And then what is ay? Ay is nothing but minus g because you're measuring it downwards. Thus, let us use the equation sy is equal to uyt plus half ayt square. Y equation of motion because acceleration is constant. So let me substitute minus h is equal to uy is 0 and this is minus half just a moment, my pen is giving me lots of trouble. Okay. Oh my God. Minus half into g into t square. Now what do I need? I need to get the value of h. So this minus and this minus goes away. So this implies h is equal to half g t square. Now substitute the values half into 10 and what is the time taken? 4, 16. Okay, 4 square 16. So this will be 2 5s are and 5 16s are, which is equal to 80 meters, right? So the right answer is 80 meters. Okay, it's not writing. Just a moment. Let me take up this pen once again. 80 meters. Okay. Next, let us look at this. A block of weight is suspended by two strings of equal length. Okay, equal length. The strings are almost horizontal. Now, what is it correct about the tension in one string? Tension one of the string. Let us draw the free body diagram for this. There's a tension here. There's a tension here. Let me assume that this angle is some theta. This angle is theta. So therefore, now if I draw the free body diagram on this direction, you will have this T, I can split it up like this. So this is my T over here. Now this is my angle theta I have written. Along this direction, this should be T cos theta. Along this direction, this should be T sin theta. The same is applicable for the other string also. I can now write T sin theta along this direction. And I'll write one more thin line here, T cos theta once again. And the weight is acting downwards. So, which should be W over here. So now, if I write down the full equation, what do I get here? I can say that this component and this component will cancel each other because they're oppositely directed. But here it is forward, it's in the same direction. So I can now write 2T cos theta is equal to W. Or T is equal to W by 2 cos theta. Now, if you notice this, the value of theta is very, very high. As the value of theta increases, what happens to cos theta? Decreases, right? When theta approaches 90 degrees, the value of cos theta will decrease. Okay, so therefore, so as a result of this numerator, let us say, for example, for this angle of theta, let me assume, okay, that value of cos theta is equal to some 0.1. 2 divided by 2 into 0.1, which should be equal to W by 0.2. Okay, W is by 0.2, which is nearly 5 times W. Okay, now, if you look at this, is T less than W? Definitely not. See, if T is not even equal to W, it's 5 times W. If I assume this is 0.1. Okay, now, so therefore, this is incorrect. T equal to W by 2? No, incorrect. Is T greater than W by 2? T is equal to 5 times W, which is definitely, it is not equal to W, it's greater than W. So therefore, T is greater than W over here. And then W by 2. And now there are two things coming over here. So here I've got T less than or equal to W and T is greater than W over here. Which one is correct? Which one is incorrect? That's what we need to look at. Now towards it, what we do is, let us take we are taking the minimum value of theta. What is the maximum value of theta? Maximum value of theta could be that the string completely sags and comes down. Okay, which means that you have the weight like this. You have the weight like this. It's like this over here. So if that is the case, this will be your theta. The value of theta here could be 60 degrees or maybe 30 degrees. Let me take 30 degrees. If it is 30 degrees, then what will happen? Then I will get this as T is equal to W divided by 2 into cos of 30, which should be equal to W itself. Cos 30 becomes half, becomes W over here. Okay, can it become 9? Can it become 0? It cannot become 0. It says strings are almost horizontal. Okay, so therefore there is a possibility that T can lie between W by 2 and W. Okay, so T can be greater than W by 2, definitely. Okay, but it can also be less than or equal to W. You can state this. But if you look at this, the strings are almost horizontal. When you say strings are almost horizontal, then which could be the right one? You cannot have horizontal condition of 30 degrees, right? You can have it only here. So D is the right answer. Okay, so we have come to the end to this. Thank you, friends, for watching this video and making it so patiently, because there are lots of glitches in my notepad. But anyway, we'll see in the next video a few more problems on it. Thank you. Keep on practicing it, keep on learning, and do not forget to subscribe to my channel for getting more updates. Thank you.